All right, so let's start talking about gases, right? Our first phase of matter. So just kind of review from before. Remember that gases take the volume and the shape of a container, right? So that's kind of the macro approach. And then the micro approach is that they're basically kind of molecules or atoms flying all around the place. Fly around, right? So if you think about kind of what the molecular picture of this looks like, so this square will be our container, and then we've just got gas molecules, whizzing about. Sometimes they'll hit each other, sometimes they'll hit the walls of the container, all that kind of stuff. So one thing to remember is that these molecules are really far apart. So we'll go with really far apart. And later on, this is going to show an effect that basically most gases behave approximately the same under standard conditions. We'll go with normal. Cool. So as we can see here in this little picture over here, you can see that every now and then they're going to collide with the wall. And when they collide with the wall, they're going to exert a force. Right? If you try to hit something, you're going to exert a force on that. Same thing with these gas molecules. They're flying around. Sometimes they'll hit these containers and they'll exert a force on it. And so what this results in is gases having pressure or exerting pressure, because pressure is defined as a force over an area, right? So gases exert pressure. It's the reason you can fill up a balloon with your breath, right? You blow gas molecules in there, and those gas molecules are whizzing around, hitting the containers or hitting the walls of the balloon, causing it to kind of expand and stay expanded. So there's multiple ways to increase the pressure of a gas, right? The most common ways are just going to be add more gas. Gas molecules per area, right? So if you do that, you're going to increase the amount of force you have, and you're going to increase the pressure, right? So if you have a balloon and you blow more air into it, it's going to expand because the pressure of the gas is increasing. So it's pushing out that balloon further and further until eventually it pops. So that's one way to have more pressure, is to just basically have more forces per area. The other way is to make this force greater, and basically that's by increasing the temperature. When you increase the temperature, you increase the speed at which these molecules are going, and so you increase the amount of force. So we'll go with faster. And we'll take a look at temperature later on. We'll see that's not quite as simple, but it's not too bad. So just some examples of some use of gases, right? Plenty of use of gases. You're breathing it. So you can, play around with one of these kind of wind cannon things. So you pull it back and then you let it go, and then it, shoots air out at people, right? So you're exerting a force on that gas, and you're basically throwing gas molecules at someone, and they can feel it. Another one is hot air balloons, right? You have hot air, which is going to be less dense, so it's going to go up to the top, and so your balloon will float. Really, this was kind of what started all the huge research on gases, because back in the day, people wanted to learn how to fly. They didn't have planes yet, so hot air balloons was kind of the starting point of things, and so naturally they wanted to study gas so they could control it and make better hot air balloons. And then finally, the weather. The weather is predominantly controlled by the pressure of gases, right? So these highs and these lows that you see on the weather channel, they stand for high pressure and low pressure. And as you probably know, the air is going to go from high pressure to low pressure.